Alright, now it's your turn to try. You will see on the screen that there are 6 examples of triangles. Now, they're built all different directions. Some move left to right, some are flipped around. It doesn't matter. Here's what I want you to do. I want you to take your the video and pause it, and I want you to try all 6 of these. We'll come back in a minute and see if you get the right answer. Remember, you're going to use the Pythagorean theorem that we used in the last video to solve for the side that they don't have. Let's see how you do. Alright, let's see how we do on each of these. Now, the first thing I'm going to do is, just in case you didn't know, I'm going to go ahead and put in the X's. Let's say, I don't know that one, I don't know that one, I don't know that one, this one, and this one. So in each of them, the X is not in the same place, so I'm going to go ahead and zoom out, and then we're going to work a couple of them, see how you did. Now, number 5 may have been a little confusing, but we'll work that one out here in a second. We'll see if I can get it right. Number 1, I want to basically draw the triangle. Doesn't have to be perfect. 3, 4, x. A squared plus b squared equals c squared. Now remember, as soon as you see a right triangle and you're trying to get a side, if you don't remember the formula, go to that math chart that they give you and find the Pythagorean theorem. A squared, okay, we'll call this A, we'll call this B, and we'll call this C. Remember, C is always the longest side. A squared, 3 times 3 is 9. B squared, 4. 4 times 4 is 16, is C squared. 9 plus 16 is 25, equals C squared. Got to take the square root to get that square to go away. 25, what number times it? 5. 5 times 5, there's the answer to number 1. 5 times 5 is 25. Now again, if you're not sure, use your calculator to help you, because your calculator will help you with the numbers you need to know. Now let's do number 3 real quick. Question number 3 is a really long triangle. Now, I didn't draw it very good, but it's good enough for what I'm doing. This side's 24, this side's 25, and this is x. Don't know that. So across from the 90-degree angle, that's c squared. So a squared plus b squared equals c squared. So this is going to be 25 squared. And it doesn't matter which I pick. A is this one? Sure, this can be b. A squared is, I don't know, 24 squared. I don't know that one off the top of my head. So 24 times 24 equals 576. And I also don't know what 25 squared is, so I'm going to go ahead and do that one while I'm here. 25 times 25 equals 625. Alright, now I have numbers. Remember, I want letters on one side, numbers on the other, so I'm going to subtract 576. So 625 minus 576 equals 49. Equals a squared. So I took 24 squared and 25 squared and solved for it. Take square root. Square root of 49, well, if I don't know it, I happen to know this one, but 49 square root happens to be 7. The answer is 7. My calculator helps me out with all the work. I just have to do the work on the paper. Now let's do number 5 real quick, because that one looks really weird. Okay, that one looks really weird. Let's go ahead and draw it out. 1 square root of 3 and x. So this is A, and this is B. Remember, it doesn't matter which is which, but this one definitely is C because it's the long side across from the right angle. So A squared plus B squared equals C squared. So C squared is what I don't know. A squared, 1 squared is 1 times 1, which is 1. And 1 times 1 is 1, and then you have plus. Now, here's the tricky part on this one. Square root of 3, and then they want you to square it. I'll give you a quick shortcut. A square root and a square cancel each other out. Let me give you a silly example. Let's say I had 5 plus 2 minus 2. Well, as soon as I do plus 2 minus 2, those cancel each other out. The answer is 5. Now, I know that if I went 5, 6, 7, and then subtract 2, I'm back to 5, but plus 2 minus 2 cancel each other. That's exactly how it is when it's square roots and squares. They're opposites each other. So the square root is knocked out by the square, and all you have left is 3. So basically, when you square that, square root of 3 times square root of 3, you get square root of 9, and the number that gives you the square root of 9 is 3. That's why they basically just knock each other out. Okay, so one more time, square root of 3 times square root of 3 is the square root of 9, and if you take the square root of 9, you get an answer of 3. So basically, a square and a square root knock each other out. That's why that number's a 3. Go ahead and take that out real quick. So I have 1 plus 3, that's 4, equals c squared. But I don't want c squared, I just want c. So again, square root knocks out the square so that I just get c. Square root of 4, 2 times 2 is 4. There's my answer. See if you can get the others. If you're struggling with these, you may go see a teacher or a friend, see if they can help you with these right triangles. But you're just using the Pythagorean theorem, a squared plus b squared equals c squared, and then being really careful with moving your numbers around. Keep up the good work. You're doing a great job.